Here we go. We want to use implicit differentiation to find the y prime, and then use that y prime to find the tangent line at the point. Our equation is this one. Our point is 3, 1. Let's go ahead and do that. For the sake of time, I'm going to introduce just a couple of notations, just so we know. I'm going to use different brackets to indicate these terms. So let's call this first term 3x y squared. We'll put that within square brackets. We'll put the x to the third, y to the third within set brackets, and then we'll put the 7x y into parentheses. Okay, so we take the derivative. We know we can take the derivative of each part. In my square brackets, this is product rule, chain rule stuff. 3x, derivative of 3x is 3. Normal y squared plus normal 3x times the derivative of y squared, that's 2y to the first, multiplied times y prime. Inside of these squiggly brackets, or my set brackets, I do the same thing. I have an f and a g. Derivative of f is 3x squared. Normal g is normal y to the third. And then plus normal x to the third multiplied times 3y squared times y prime. And then lastly, in my parentheses, derivative of 7x would be 7 times normal y plus normal 7x times the derivative of y. That's going to be 1 times derivative of the inside function. So 1 times y prime. And on the right-hand side, I get a 0. I'm going to clean that up a bit, at least as much as I can. So 3y squared plus 6xy times y prime plus 3x squared y cubed plus 3x to the third y squared times y prime minus 7y, and that's going to be a minus 7x times y prime. All of that is equal to 0. I'm going to group the terms with the y primes on them. There's 3 of them right now. I'm going to leave those on the left-hand side, and I'm going to move all the terms without a y prime on the right-hand side. So the easiest way to do this, do some copying and pasting. On the left-hand side, all of the terms with the y prime are going to stay. And all of the terms with no y prime are going to go to the other side. Now, when I say go to the other side, we have to subtract them. So for instance, 3y squared, when I move it from left to right, I'd have to subtract 3y squared. When I move 3x squared y from the left to the right, I have to do a minus 3x squared y. When I have to move the minus 7 from from left to right, I have to add 7y. And I'd end up like this. Factor out a y prime, divide, we're good to go. So factor out a y prime. Again, so I don't have to rewrite this equation, I'm going to use a lot of copying and pasting. So if I factor out y prime, I can get rid of one factor of y prime on each term here on the left, and then divide by that coefficient, which means that y prime is equal to a really big, ugly looking fraction, the numerator of which will be negative 3y squared minus 3x squared y to the third plus 7y. The denominator of this fraction is going to be 6xy plus 3x cubed y squared minus 7x. Notice a lot of people will try to like cancel things. You cannot cancel things because there are multiple terms on the top, multiple terms on the bottom. What I can do is I can take this big fraction and see what happens at the point 3, 1. So I input a 3 in every time I see an x value. And then I go ahead and put a 1 in every time I see a y value. And then plug that into your calculator. We're going to get an instantaneous rate of change or a slope of the derivative of the tangent line. So the derivative at 3, 1, or the instantaneous rate of change at 3, 1, or the slope of the tangent line at 3, 1. Those are all terms meaning the same thing. Those happen by plugging in these numbers. So when I did that, the numerator became a negative 23, and the denominator became 78. That doesn't reduce very well, so I'm just going to leave that as the fraction negative 23 over 78. Finding the tangent line, we replace our m with negative 23 over 78. And then I'm going to plug in that value of m. And then I'm going to plug in the point that I know this line goes through. This line goes through the point 3, 1. Input the number 3 for x and the number 1 for y. We can solve that for b. Let me do this on my calculator here. When that's all said and done, I ended up with a b value of 49 over 26. Now check your answers because I'm doing this as quickly as I can. So be careful when you do that. But I ended up with 49 over 26. So that means the tangent line is the one that has slope negative 23 over 78. And we're adding 49 over 26 to that. So that's the tangent line. Anytime we have tangent lines, you can see that they can be ugly. That's just par for the course. These last few problems have been fairly cumbersome and involved just because of the way we took derivatives here. So in a second, I'm going to show you some other tricks and tips you can utilize to hopefully make your life a little bit better.